Welcome back. This is the beginning of a set of 4 lectures on kinematics in 2 dimensions. Kinematics, the first 5 that you saw were of kinematics in 1 dimension. In other words, the motion was either going vertically or horizontally. In this one, the motion is going both horizontally and vertically. So here's the website that you can get your notes for this set of lectures, http://db.tt/5 lowercase c, capital D, capital C, capital H, capital G, 4 lowercase p. Before we get started in 2 dimensions, we're going to kind of what we would say resolve our vectors. These equations, you probably recognize these in math. This is nothing more than finding the x component of a line. This is nothing more than finding the vertical or y component of a line. This is your length formula, square root of, if you think about it, a squared, b squared. And this is to find the angle of the line that you draw if you know the y and the x, which is the inverse tangent. Remember on these, on the angles have to be in degrees, so if your calculator is in radian mode, change it right now or you will get some really weird answers. So let's just look at this first one. It says the following vectors, and say for instance I've got an object of some sort. We've got 60 newtons at an angle, acting on at an angle of 40 degrees, 100 newtons at 120, 500 newtons at an angle of 270 degrees, and I want you to say, okay, what is the net force and which way is it going? So actually the net is the r, and that's a square root of x squared plus y squared. And I want to know the angle, which is theta is equal to the tangent, the inverse tangent of your y over the x. Now we need to find the x and y components, so what we're going to do, we're going to go back to these 2 equations here. So I would say that x is equal to a cosine of my angle, and my y component is equal to the sine of the angle. So here's what I'm going to do. I'm going to find x for the sum of the x's, sum of the y's, and then just put those into the resultant formula and the angle formula. Just want to remind you, this is how you do it. I am not solving the answer for you. Okay, so our x, the first one for the 60, all I'd say is 60 cosine of 40. Put an s in there. And I'm going to get a number here. And then the next one, I'd have 100 cosine of 120. And the last one is 500 cosine of 270. Now I'm going to get some numbers here, here, and here. I'm going to add these numbers up here, add all 3 or 4, or how many you have. This even works good for 2, and I'm going to get a sum here. So this is sum of my x's. Do the same thing for the y's. So y is equal to 60 sine of 40. I'm going to get a number. And then 100 sine of 120. Give me another number. And then 500 sine of 270. Get another number, and I'm going to do like I did over on the x's. Add my column right here, and I'm going to get a sum. If I can write sum, there she is, sum of the y. So all I'm going to do with this number is take this, plug it into there. Don't forget to square it. Take that number, and there you can find your r. and then define this. I take this, put that there, and take that number and put it right there. Do an inverse tan function like your geometry teacher taught you, and there it is. And we'll quickly do one more. Okay, so I want to find the r, x squared plus y squared, and my angle is going to be the tangent, inverse tan of y over x, and then I'm going to say x equals, almost forgot the x, cosine theta. Don't forget you're in degrees. Now you notice the first one was in newtons, this work is in pounds. It works no matter what, since that's the units we're dealing with. It's 150 cosine of 350. I'm going to get a number here, 200 cosine of 260. Get another number, 150 cosine 110. And get another number. Remember, add them so you can get your sum, your x sum, and then your y is equal to a sine of theta. So this one is 150 sine of 350, and you're going to get, let me scoot the paper over for you. You're going to get a number here, and then 200 sine of 260, another number, 150 sine of 110, get another number. All you're going to do is just add these together to get a sum of your y values, then plug it into your resultant formula and your angular formula, and there it is. Now this is a mathematical. Your teacher might have you do it graphically, but this works out just as good, or you could use it as a check for your graphically. Remember, if you have any questions, feel free to contact me.